Okay, simplify the expressions. So if I have to simplify an expression, I need to know my operations. It's a power, power. So how do you simplify with times and powers with the three lines? So you have 5 times x times y times x. So 5 times x times y. A second factor of x means I just add to the first. So I got a 1. 1 times 4 is 4. There's 2 x's, so I'd have a 3 times a 4, that'd be 12, and then a 9. 12 plus 9 is 21. And the y, 3 times 4 is 12. Okay, that stays in position. That stays in position. That stays in position. Okay, now, caret this guy. That's 625. Then the letters stay the same. Okay, nothing on bottom. If you want to put a 1 on bottom, you can. You don't have to put a 1 on bottom. You have to put it on top. Okay. Number 2. So extend the line. We have 9 with a power of 2. Times 3 times x, power 3, power 4. Remember, if you don't have an operator there, it's times, okay? And then x times y. So on top, you got 9 times 3 times x. On bottom, you've got x times y. So we will be canceling the x's, but I have to know what power I have. So 9 to the 1. 1 times 2 is 2. 1. 1 times 4 is 4. Okay, x, 3 times 4 is 12. Won't be 12 for long because there's an x on bottom it will cancel with. 1 times 2 is 2. And 1, remember it's in parentheses, you got to distribute out, that's 4. Okay, these two that stays in position. 3 to the 4 stays in position. X to the 12. Oh shoot, I didn't cancel. Dang it. Okay. You need to cancel that 2. So it's x10. You minus it. Okay. x10. And y to the 4th. Okay. So 9 times 9 would be 81. 3 to the 4th, that'd be 3 times 3 times 3 times 3. That's 81 as well, incidentally. Okay. And x to the 10th. And y to the 4th. You multiply 81 by 81. Okay. 6,651. Okay. Number 3. Put in your operators. So you got a 3 and a 4 times an x. So 3 to the 1, not in parentheses though, so it's just a 1. The parentheses is on the bottom, so both of these, 1 times negative 2 is negative 2. 1 times negative 2 is negative 2. 3 to the 1 stays in position, but he's about to be joined with these because they have to switch. Okay, that's a stay, that's a switch, the 4, and then it becomes 2 up there. You switch it so you can have a positive power. X. Okay, 3 to the 1st is 3. 4 2 4s is 16. Then x to the 2nd. So 3 times 16 is 48. So I end up with 48 times x to the power of 2. Okay, number 4, parentheses 2x to the negative 3rd power. So you got times and then a power. So 2 times x. 1 times negative 3 is negative 3. 1 times negative 3, negative 3. Okay, it's negative, so you have to switch that to the bottom. Same with the x, has a negative power, then that base switches out into the other position, and it becomes positive. Okay, 2 to the 3rd, you don't have anything on top, you're going to put a 1. 2 times 2 times 2 is 8. Then x to the power of 3. So 1 over 8 times x to the third power. Okay, scientific notation. Simplify. Write each answer in scientific notation. So we have 4.3 times 10 to the fifth. This is a whole number. I'll call it number 1. We're multiplying by a second number. Call that number 2. So to multiply this, you need to multiply your standard numbers, the 4.3 times your 3.2. And then you need to take your 10 to the fifth times your 10 to the negative third. Okay, 4.3 times 3.2 is 13.76. Now, your base 10s, you add the exponents, okay? Add them, that's 2. However, the decimal is not where it's supposed to be. It's supposed to be right after the first number, as long as that number is not a 0. And the 1 is not a 0. So I move it once to the left, so I add 1 to the power. That's 3. So 1.376 times 10 to the third power. Okay, number 6. That's number 1. That's number 2. 7.2 divided by 9, and then 10 to the 7th over 10 to the negative 4. So 7.2 divided by divided by 9 is going to be 0.8. Okay. Keep in mind for later, you can't have just a 0 in front of it. You'll have to move it so it's behind the 8, but we'll first figure it out with the exponent. Cancel. Remember, it's minus negative 4 because it was a negative 4. 7 minus negative 4 is 11. Okay, so you move the decimal so it's behind the 8. So then you minus 1 when you move it to the right. So this is going to be 8.0 times 10 to the 10th power. Okay, the next part, you get these annoying graphs. Y equals 4 times 1/3 to the x power. Basically, your best bet on an exponent function is just to do an input-output table with integers, inputs of 2 through negative 2. Now, there are more inputs than that, but just to get our graph down, that's all you have to do. So 4 times parentheses 1 ABC3 caret 2. So I got 4/9. Makes sense because that'd be 1/9, and then times 4 is 4/9. This one here, you're going to get 1 1/3, because 1/3 to the first is 1/3, but multiplied by a whole 4 takes you to 1 1/3. Put in the 0. This is 1 times 4 is 4. This is going to be 12 because the negative exponent flips it to 3 over 1, which is 3 times 4 is 12. Okay. And this is going to be 36. Because 1/3 of the negative 2 power flips the 1 over 3 to a 3. And then 3 to the regular second power is 9 times 4 is 36. Okay. Alright, we better go by 5s on the y. So 5, 10, 15, 20, 25, 30, 35, 40. Okay. Alright, so do your 36 first. So this is a decay because as you go this way, all you do is decrease. Okay. It's decay because the base of the exponent's a less than 1 whole. Okay, 0, 4, and then all you do is get closer to the middle. Don't cross the middle and put arrows that way and this way. Okay, 8. Y equals 1/4 times 10 to the x power. These graphs are continuous, okay? Just our points, they go beyond those points. We just pick those. Okay, y equals 1/4 times x to the power, 10 to the power of x. And I could make you do 8 through -8 if I wanted to. Okay, it's a continuous function. Ten to the second gives you 25. Because 10 to the second's 100. You take 1/4 times 100, that's 25. This is going to be 2.5 because that's 10. But you times it, take 1/4 out of the 10. This is going to be 1/4. This is going to be -1. Okay, if you want to hit second PRB, shoot. Second PRB, 1/40th. We get crazy on this next one. Second PRB, 1/400. Okay. Obviously, those are really tiny amounts, so we're going to go by 5s on the Y. Okay, so 225. One, 2.5. Okay. Okay, remember that it's continuous, you need arrows on both sides. Okay, write the expression 8x, quantity 8x to the 1/3 power in radical form. This represents a radical. It's going to be, the radical's degree is a 3. And inside you're just going to have 8x to the 1 power. That's all you do. Okay, write the expression, the 4th root of x to the 5th in radical exponent form. So you write your x to the 5th down, rational exponent, sorry. Then, to get rid of your radical, you underline the power and just put 4, x to the 5/4 power. You can have the top be bigger, doesn't matter. Okay, number 11. You start a lawn mowing business and make a $400 profit in the first year. Each year, remember, each year means per year, and it means every year. Okay, 1, 2, 3, 4, not 0, 3. There was an assignment where you did 0, 3, 6 because it said every 3 years or every 5 years. But when it says every year, that's 1, 2. Your profit increases by 5%. If you continue your business, what will your profit be after 10 years? So you got dollars and years. X is years, Y is dollars. So per dollars per year. Now again, you don't have, there isn't a dollars per year, it's a percentage per year. Increasing of 5%. So what you do with an increase in percent, first off, you know it's going to be an expo function, not a linear function. So you take 100% plus 5%, 105%. It's going to be 1.05. That's your growth factor, okay? So you are making your table. So X is years, Y is dollars. Now remember, that percent says each year. So we don't do that 036 or 246 or 0816. It's 012. Okay? So we started at 400. Then we multiply by the factor of 1.05. Not just 0.05. You got to adjust it with the 100. You're multiplying by something greater than a whole, so it grows. 420. Okay, 441. So that's why it's not a line, because it goes by 20 and 21. And we need to find what we're making in 10 years. Now, anytime I'm multiplying over and over, we don't draw the line, okay? That's an exponent function, so we need to set that up with the template. A times b to the x power equals y. So the a is 400. and b is 1.05 caret. Now I want to get to a 10th power, and I plug that into my calculator. Okay, $651.56. If you put $52, that's, if you put $652, that would be just fine. Okay. Okay, number 12. You deposit $13,000 in a bank account that earns 4% interest compounded quarterly. How much will be in the account after 3 years? Now, you have an equation for compound interest. You don't need to make your table. You just start with the given equation. Okay, so what's P? P is 13,500. R is 14%, or 4%, but you need to make that a decimal. So 0.04. Okay, N, that would be 4. Quarterly is 4 times a year. And then T is 3 years. So P is going to be 13,500. So your rate, 0.04, divided by your N, that's also 4, caret NT, so it's 4 times 3, that's 12. Okay, so we got 13,500, parentheses 1 plus 0.04 divided by 4, caret 12. Okay, $15,212.14. If you want to just put the 212, that's fine.